Hello everybody and welcome to the video on solutions of an equation. This is also some nice review from past math classes. Generally, when we look at a solution of an equation, we usually write it as a point x comma y, and this point makes the equation true. And so a lot of the times in your past classes, and this will come up later, is it asks you, is this point a solution of the graph? Or when you plug this point in, does it make the equation true? And so this is a brief review of that topic. And something else that's really good to remember is that graphs technically are made up of infinite points. And a lot of graphs you're familiar with is the line, the parabola, cubic function, absolute value. Those are some common ones you're familiar with. And if you think about it, all of these graphs are technically made up of infinite points. So you could go on forever and ever on a line, a parabola, you happen to have a vertex, a special point there. Cubic is made up of infinite points. Absolute value, again with a vertex, is made up of infinite points. So when you are graphing something, I also want to remind you that a graph is really just a picture of all your solutions, or a picture of everything that makes the equation true. There's none of these points would make the equation false. Those would all be the ones that are off of the line, off of the parabola. So it is good, especially since some of you, I totally understand, graphing is your least favorite thing in math. I completely understand that because it's tedious sometimes. But remember, the reason we ask you to graph is because we want you to visually represent all of your correct or true answers. Something else that you've seen in your past when you hear the word solution is some of you might go back to the idea of a parabola. Especially when we did factoring and quadratic formula, if you're focusing specifically on quadratics, just for a little review, remember that a quadratic could have two solutions where it crosses the x-axis. Your parabola could have one solution if it grazes the x-axis, so you could have one solution here, or you could have a third situation that your parabola or your graph in general does not touch the x-axis, which means you would have zero solutions. So I wanted to bring to your attention that solutions could mean two things. Solution in the grander scheme of things means any point that makes the equation true, but in terms of quadratics, it means where it touches the x-axis or how many times. So they're used interchangeably. And if you think about it, these here go with both definitions. They're both touching the x-axis and make the equation true. So moving on to our example. Use two different methods to show that the point 2, 0 is a solution of the equation. Now, I can think of probably 4 or 5 ways you could show that this point works. And what I'd like you to do is just brainstorm for a minute. I would like you to try or write 1 or 2 methods that you think you could use to prove that 2, 0 is a solution of this equation. And notice it is quadratic. So please pause the video now, write down some work, and I will do the same, and I'll show you my options when you get back. Okay, so I wrote out all my possible options, and you might have had multiples of these, 1 of these, 3 of these. I had 4 possible options that I came up with off the top of my head. So when I saw the point 2, 0, I really thought of it as x, y. So one option I could do to prove if it works is I could plug in x equals 2 in here and see if my y value matches this y value. And so when I did that, I squared the 2 and got 4, minus 6 plus 2. I got y equals 0, which is what I wanted, so I knew that it is a solution, but here's one option. A second option could be doing the opposite of that. You could plug in y equals 0 here and see if you get an x value of 2. So when I did that, I said 0 equals this quadratic. I factored that quadratic and got 2 possible answers, one of which is 2. So 2, 0 worked in this case also. Option 3, you could plug in 2 and 0 at the same time. to see if both sides end up being the same number. So if I did that, I got 0 equals 2 squared minus 3 times 2 plus 2. And after I simplified, I got 0 equals 0, which is a true statement. So I knew that was another way to prove that this is a solution. Option 4, you could by hand or with your calculator graph the function. And you could use your calculator to look at your table, look at the picture, maybe even look at the x-axis to see where it crosses. If I were to graph this, my parabola would look something like this, probably going upwards, hitting the x-intercepts of 2 and 1. How did I know the x-intercepts were 2 and 1? It's because when I factored, these would be where I cross the x-axis here. So my picture would look something like this. So I could see that it crosses here at 2, and I know 2, 0 is a solution because it's on my x-axis. So all of these variations are very close to one another, but this is how you could prove if it's a solution. Really what you want to try to do is plug in this point in some way to see if it works. All right, guys, that's solutions of an equation. Thank you for watching.